Welcome to this lecture. Now we're in the journey to make the complex payload, or basically the reversal in the upcoming lecture. But before doing that, let me just tell you the concept of a threading. It is a very powerful concept in the Python and in any programming language. So just remember that if you have any processes that is running on a machine, then there will be the main thread that is executing it. So there will be the processes that is doing that program. So let me show you what I am talking about. So first of all, let me just go to my Kali Linux over here, and I'll just say that open me the Python. So here I'll just create a new file, Python file. So I'll just drag this right here, and in this Mac changer, basically we have to change this file name or folder name, but for now I'll just give you the simple example. So I'll just say demo is my file. So here you can say that if I run any program, maybe say main, and here if I just write the print statement saying or something like this, and now if I say that this on main, then you are executing your main thread. Basically this is the way to just execute the program, and you can see we are just doing one task over here. So it won't be problem if you are doing one task or the multiple code, because you are simply executing a one thread, and that won't take any time. But let me say you have a multiple function to execute. So instead of function, let me just go away and create a whole class. So let's say I have a class, and this class is one class, and we have now another class, and that class will be two class. Okay, this will be two class, and then go here and just define some functions. So first of all, I'll just say run is the method, and here what I'm gonna do is I'll just say that let me just print. So before printing, let me say I want to use this for loop, and I want to make the range 0. What is the use of the range? That is to create the list of the numbers, and I'll say u50. I want this execution, and I'll just say print that is class 1. So it will just print me 50 times class 1, and I'll also define the same function over here, which is also the run method. And now what I'm gonna do is I'll just do the same task, but for now I'll just say I want this again the range, which you can clearly see will print that is class 2. So let's do this real quick. So now you can see we have these two tags. So these tags are happier than before. So what you can do now is make the instances of this class, and you can simply run this method. So first of all, I'll just say 1, and this one will be created with this one class, and after that we'll just run this one. So before that, let me also create the 2, which is the object of these two class. So we have now created the object, and next thing is to run this method. So in order to run, we have simply that is run method, and the next is to call this to and run method. So we're doing simple things over here, so nothing fancy. We're just creating the object and the classes of that, and basically we just see the templates over here. We're just running this run method. So you could see that it is more heavier than before. So that in the previous case we just running some function that was having the simple example, but for now we have the more tasks to do. That is, you have to first run this one and this one, and this is for the 50 times. So if I show you how this will be done, so let me just go over here and just press this demo. You'll see that it will have this class 1. First you can see the sequence over here. What it has done is basically it has just printed out the class 1 first. So you can see no class 2 has been printed over here, and after there is execution of class 1, which is printing 50 times, it has now started printing this class 2. So you could see there is a time waste over here, because you could see our CPU, or basically our processor, is more capable than this. Our processor can do multiple tasks at the same time, because it's a multi-core. You can have the octa core, you can have the data core. So there's a powerful processor available nowadays. So we are only limited to this task, because because it is basically not using the time sharing technique. So if you see in this any of the application that is happening in around us, basically in the Windows, if I just see the MS Office, or if I just open any game, maybe if I run any game in the Windows, then you will see there will be multiple processes running at the same time. That is available, or that is done because of the multiple processor, and that multiple processor supports multiple thread. So you can take the example, maybe I'm just giving some, maybe I'm just playing the Counter Strike, and you could see in the Counter Strike there will be multiple processes running. So here you can basically go around, and basically that is the movement for the player, or you can also see the enemies, and you can see the movement of different players. So that is basically the thread. So every player has its own thread here. So that is very important on the thread, because thread will now be explained as a division of the processes. So what happens is you have a main task. So let me say the task is playing the Counter Strike. So in that Counter Strike you will have the multiple thread. That means each player in the Counter Strike represents a thread. So thread is a particular or part. It is only the part of the processes, and one processes will have multiple threads. But if you run only one process, it will have the main thread and the execution, or simply the different part of a thread. So just remember that now what you can do with the help of thread is you can simply see in this result now, because it is time wasting now. Basically it is not a reliable program, because it hasn't printed something that is simultaneously. So basically we are getting the output, but it is taking more time than what our processor is capable of. So in order to make our processor works faster, we have to make use of threads. So what we'll do is we'll just run this run on the one thread, and we'll just make this object, or basically this run method, to work on the next thread. So thread will support the multitasking. That means you can do multiple tasks with the help of the threads. So let me say from threading, which is the class that is available to just use the thread in your project, I want to import everything. So what we have done here is from threading, which is the module. So let me go back over here and show you the threading module. So it is showing that threading is used for thread-based parallelism. That means it supports the multitasking. You can do multiple things simultaneously using this threading module. So instead of just, you can go back over here, and instead of just running one by one, which was done here, which was seen over here, that is, first of all, class 1 was printed, and after class 1 is done, class 2 was printed. So instead of that, we want to just print everything simultaneously. So it should print class 1 first, and class 2, and again class 1. So it doesn't matter which thread first prints, or basically which thread work, but there should be time sharing between these processes. So in order to support that multitasking and time sharing which our processor is capable of, we have to use this threading technique. So let's go back here, and you could see that we have the threading module over here. So it has shown this active count, current thread, and basically the main thread. What we are interested is maybe let's go down. You could see this daemon. We have to use of this daemon in the next lecture, where we just make our own reversal, and you could see that it is showing that this daemon thread is basically where you run your entire program. So if entire Python program exists when only daemon thread are left, so this flag will just learn about this when we just code. So don't worry about that. So things here is this class over here. So this class is important. You could see all of these arguments, and it is saying that this constructor, which is basically the thread constructor from this threading module, should be given with this keyword argument, and we'll see about this. And about this daemon and quarks and args are basically the tuple we have seen in the packing and unpacking the arguments. And next thing is you can see this run method. So I want to show you this here. So what happened is this is the method representing the threads activity. So if you see here, I wasn't making this run method randomly. So I could have made something like maybe method, or basically I'll say that I can make this info. If you will make this info, it is not going to work in the case of threading. So I wasn't making this run purposely, or basically I wasn't making this run method randomly, but this run method is the method of this threading class. If you could see here, it has clearly shown us this is the method which you can override in the subclass, or basically you can go to the thread class and you can see that there you will see this run method. So what we are doing is basically there is a run method in our parent class. Now we have to just override that run and we'll just do that is our own code. Instead of running that run from the original class or basically our parent class, we'll just run that thread from our subclass. So this is overriding. So let's see how we can just implement this. So in order to implement the thread, we have imported everything from the threading class. Now we have to make use of this thread class in the subclass. So thread will be your main class or the parent class. This one will be your subclass. Let's do that for the two class, and I'll just pass again the thread. So now you can make use of the thread. So you could see now we have made use of our threads, but still it is not going to be successful, or basically this is not going to run simultaneously. Let's see if this runs or not. So let me just run the demo again. This is not going to work. You could see clearly class 1 is printed first and then class 2. It is not running simultaneously. If it has run simultaneously, or if that thread was running simultaneously, it should have gone something like thread class 1 over here, class 2 over here. But you can clearly see first of all class 1 is executed, after that class 2 was printed. That means we have not succeeded yet creating this thread. So thread are not yet created. So in order to just run this thread, you have to make use of this start method. So instead of just run method, you have to use start method. So let's see, let's go back over here and you could see these are the two methods that is very important. So first of all is a run method, and this is important because you have to run your program into the thread with this run method. If you make any method in the class, let's say instead of run, you will say running, then this is not going to work because this method is not inside this thread class. So if you want to just override or make your program to run into the thread, it should be inside this run method, and this is compulsory, this is mandatory. And next thing is this start method. So you can see we have made the object of the classes, and in order to run this method, which is to call the run, which we normally do in the object-oriented programming, is simply we'll just type the object and the method we want to call. But in the case of threading, you have to use this start method in order to run this method. So let's see how this works. So let me just run this now. It should now create us a two thread. Still, this is not creating us any thread. You could clearly see that class 1 was printed first and then class 2 was again printed, but we have succeeded in making the thread if it has not printed yet. So let's see how this threading works for this larger digit, because yet we haven't created that task in order to run the thread, because it is simply going with the main thread because the task is smaller. But now let's see if the task is bigger and this is going to run our task or not. So let's see. So still you could see that now you could see over here. So there is a combination over there. You can see here that it is saying class 2 and class 1, and basically there is saying instances. There is also the class 2 and class 1. Here is class 2 in the class 1. So now the task is so large that it has now created the two thread where we can make each processes to run on the independent thread. So you could see our processor is so fast now that it doesn't even take a time to print this. So let's see if there is any differences between this class 2 and class 1 time. So for that I want to make a sleep for every operation on this class. So in order to do that, we have the module that is time. From time I want to import the sleep method, and after printing every that is print from class 1 and class 2, I want to sleep maybe 1 second. So after every print I want to sleep 1 second. Let's see if this works, and we can see the two threads running together. Run the demo again, and let's go real quick. Okay, so you can see now that the two threads are running together. You can clearly see class 1, class 2, class 1, class 2, because now every time we just run that module or basically run that class or the thread, they are running simultaneously. So this is your threading technique. What we did was we just make the multiple thread in order to run the processes quickly than before. So if you just stick to the main thread, it is going to take a more time if you are doing more tasks. But if you are doing the smaller tasks, that will be really fine. But if you are doing much more tasks, or basically if you are doing very high tasks, then creating a threads running simultaneously on the thread, the processes is very much faster than before. So that is importance of threading. We'll make use of this threading while making the reward cell in the upcoming lecture. So see you in the next one. We have already seen the teaser in the previous lecture. Now let's start making that backdoor from this lecture onwards. So first of all, I have opened my PyCharm in the server side. So this is basically our Kali Linux. So in the Kali Linux, which will be our server, so let me just create a new Python file. So let me say this is the backdoor. And now we have created the now backdoor file in this Kali Linux. So you can clearly see this is my Kali Linux, which is server side. So let's start importing some of the module. We have seen how this socket module works, because it is the module that will just communicate between these two server and clients. And next one I want to import is OS module and the time module. Let's see threading module. We have seen about the threading. Now let's get that threading into the action by making some of the threads to run the multiple processes simultaneously. So next thing I want to import is queue. So from queue I want to import this class, which is queue class. So if you see, the queue is similar to that of list. We have already learned about the data structure, that is a list, which was usually inside this code, or basically inside this square bracket. You can simply put any element inside this queue. So basically this is the list. But if you see this list is unordered, that means you can just get every element from this list. You can see that you can just get these two elements from these indexes of the list, but in the case of queue, this is not possible. That is only difference between the list and a queue. So in the case of list, you can access every element, but in the queue, you can access only the end of the element. That is because it starts with first in, first out basis. That means you can only insert to the beginning and basically get out the element from the last. You cannot access the middle element in the case of queue. Just remember that you can only insert to the last, and you can insert basically to the last here, and you can only get this element out from the queue one at a time. So that is basically the difference between the queue and the list. It is quite similar in the case of processing, only you cannot access the middle element in the case of queue. So let's see, first thing I want to make is the threads. So I want the two threads to be running simultaneously, and let's say jobs. So let's say jobs will be one at a time. So I'll just make a list 1 or 2. There will be 2 jobs that will be created, so that will be stored in this list. So it is only the jobs. So let me just remove spaces from here. So next thing I want to make is instantiate this queue, because we want to run this queue to make our job, or basically to execute our job. Now we have just instantiated that queue. Let's make the array addresses. This is very important, because we have to now capture these addresses in the form of list. These addresses, or basically these addresses will be of the client, which will be our window machine. So there can be multiple clients that want to connect to this server. That means we have to make this list, because there may be many connections. So let's say another will be our connection, because there is addresses, there will be multiple connection even. So let's say this should be also the list. Now let's make our host. So host will be single host, that is the IP addresses of this Kali machine. So you can also get your IP addresses by simply going over here, and let me just type IF config. So I have already typed IF config, and you could see this is my IP address right here. So you have to just type your IP address in this field, which is string host. So next thing is the port I want to listen. So I want to listen in 4444 port. So next thing I want to do is the buff, which is the maximum characters that it can receive. It will be 1204 bytes, which is 1 MB. So next thing is to create the function. So let's see how we can just create the function. If you remember what we have learned about the anonymous function or a lambda function in the packet or unpacking argument section, or basically in the function section of the basic Python lectures, then you could see we can simply create the lambda function without the definition. So let me just close this one. So what we can do is we'll say first the decode UTF. We are using the version that is the Python version that is 2.7. You do not need to do this, but if you are using the newer version from maybe 3.5 plus, then you have to just call this function first. So let's make this lambda function, which is anonymous function, and I have to pass argument, which is data, to this function, and we'll just decode this because this function is going to just decode. So I'll just decode it with UTF-8. So this is the function to just return decoded UTF-8. So let's make another function, and this will just return the string with quotes removed. So we'll just need this in the long run. So we'll just make here, because this will be also the lambda function. So I'll just pass this string, which will be argument to this function, and I'll just replace. So what I'm going to do here is I'll just replace now with this double quote. Let me just give this escape, and again this. So what I really mean here is this escape characters will identify that this is to just remove or replace. So if there is a double quote, I want to just replace with this nothing, but basically with the empty string. So if you want to just remove this escape character, that is not going to work because this will not be included inside this string. So you can say that this is now the invalid string. So if you want to just include double quote inside your string, you have to give this escape character. So now we have included that inside our string. Now next thing is to create more functions. So let's see what next we can just create. So first of all, let me create a function that will just send the data. So what I really mean is this function, which is send function. We have seen the layer of our socket programming API call, and this was the same function. So what this function is going to do is this is going to send the data based on the connection that is sent. So if you see here, we haven't made the connection object yet. We'll just make this in a minute, but this is the function that is going to send the data. So next you can just see that next function will be obviously to receive the data, and the data will be received, let me say buffer, and here you have to make use of connection object again. So I'll just say so connection is basically the connection that is done by the socket module. So we'll do that in a minute. We have already seen that how to just connect in the previous lecture. So that will be exact what we are doing in a minute now. So first of all, instead of just making everything right over here, let me call one method. So quick method, this will be method that will receive the large amount of data. So let's make that function. So I'll say that is receive, and receive is already created over here. So let me say receive all. So this is the function that is going to get a large amount of data, so in the form of buffer. So I'll just say byte data, and this is the way to get the byte data. So now we have included the byte data. So let me say it is byte data. Now let's accept that buffer. So in order to accept that buffer, let me just make a while loop, and this is the continuous loop because the data can become continuously. That means we have to make use of that loop, and I'll just take a part of that data. So first of all, we'll just take that part which is using this method, receive method that we just created over here. And the next thing is I want to check the length, because I want to just get that data length in order to just save my now I am the data. So first of all, let's take basically the cell that is for doing that. So what we have to do is just take the concept of everything that is very important and not implied in any programming language. So just remember that if you have any process that is running on a machine, then there will be the next part you have to just see it. So there will be the processes where that is doing a bad program. So what you want is to I first of all, so basically not so forward to my colleague. This is not the real data that I want to use my body sound. So here I'll just create my new data as a Python of my data. Basically what I'm just saying is, so let's see that data, just taking my change that is the part to the host. If I want to put the same word for the right, you will use the same example. So I'm just saying it's a whole lot that my file is so they can just say that if I buy or provide a part, you can say no, we will just continue to make it by just right. And now let's step again, same that is again all or something like this. So let's change now the same step. I say that if this point me data now never executing your main is basically this is the way to just execute the data, and you guys have to just see one data. So it would be the goals if you are seeing one data on the mind code that you are simply execute. So one flow and that one is any down. But let me say now you have a style function or something. So instead of function, so let's just go down and the whole class start making. So I have a class, so this class is my class make is, and we have now socket other class, and that class we have already seen how to use the socket. So first of all, I should say to class, and let's go out here and just find socket function. So first of all, I'll just say object is on this one, and here that is whatever visible. I'll just say that this is a behind. So it is one day or to look. I want to see to use this for visible sentence. I want to display so what is also is that also is placed of the numbers. And also let's take out how what is execution is, and now this socket if we don't connect this class one. So first we just play to the second line. Okay, that's class one, and I'll also use the same function. So it's also the one that through this and the socket, but socket is I'll just do the same task. But for now, I will say that this socket I want this. So let's say add the socket is option which I have to the socket. You will say object socket is class 2, and it should be this option. So you can see when I want this to type. So this task is an option in this socket. So what I want to now is make instances of this class, and you can simply run this method. So first of all, I'll just say one it, and this one will get created for this one class in the end. After that, we'll just do the next one. So I'll that I want to keep which is set of these two classes. So I have not created also this will be the next argument, and next thing is to run this method. So the point we have simply this one run method. So if you see our answer, next thing is just compose this to if I run not connected to where this was things over here. So when you can see we're just creating an object next classes to of that and basically we just see the exception on your so we're just running this that is going to see that it is more heavier than before. So that in the previous case we just running here some function as having a simple example and for now I have more tasks to do. That is you have to first run this one and this one is coordinated also so that you have this one connection. So I say just press this demo, you'll see that you have this class 1 exception. First this you can see the sequence over here. Just what it has done is basically it's just figured out so class 1 first. So you don't see no class 2 has been created over here, and after the execution of class 1 completed on the socket. So it has been start this program is class 2 create the socket. So basically is a line is way because you would see so how I see you are basically our processor is more capable than this. Our processor can define but answers without even multiply. So have the output you can show take a course of cities about issues so you will not so much with I only see that yes just because I used to basically say and not be like before serious. So if you see in your voice any application that is we have in our house basically in the voice to devices yes always I feel so maybe saying maybe it's okay to ask yes it always goes so if you are in your processes running at the same time the study develops but that is done because of the model process of what I can do in the processes suppose somebody was there and so look at the example maybe I'm just thinking so maybe I'm just playing the counter stack and if you see in the counter stack you're using multiple processes so you can basically say oh there's everything so what made me was here because you see so you can see that some moment of different layers so that is basically the thread so every player has his own thread so that was the important of the same because right here we was before explain it just give us some messages so what happens is you can have some main tasks so next thing is start displaying the context so that you can always take you have this like that means each player the context and it is on zero and three so what it is a particular it is only the part of the processes every one processes will have multiple this point because it is one process and it is will be and there is simply different part of the process so this is something that now is to the regions you can simply be saying this is just now because it is time was the now it is to know the level because it has a sweet it's something that is already seen so basically we are getting the output but it is taking more time than what the output is going on so in order to make our processor work faster we have to make it so what I just is you just run this surrounding so and we just find this object basically it's not just about that we are on the next thread so thread will support the multitasking that means you can do multiple tasks with the help of the threads so let me say from so we thread if there is here that is available so okay we just see you so now we have also checked I want that board socket so next method I want to query on here is to socket which is the module so this will be over here and show you the recording this way so it is showing the exciting is between the solver and parallelism that means so the last method you can use multiple things simultaneous socket exception the last thing to the other socket so instead of just say so instead of just serving one with one doorbell which was seen over here for I see the same first one class 1 was so it is not for class 1 can be done class 2 was persuading so it's still at that so one so this make something simple so it should be class 1 first and class 2 negative class 1 for so it doesn't matter which class at first is everything connection work then you will just get time saving within these processes connect so in happening so then multitasking which every time CI which our system is capable of we have to use so much that you just express it back here and you can see that we have the very much over here also it has shown over here active count so it is really connects this is the best way to just get us this connection is then let's go down and let's see this September next thing we have to use of this in my next notes so we just coming out because after the reverse I see that one it is when that's this September I will put here one basically where you get this one in that program so if in that Python program exists when only demonstrate I see I want to do this I was not now this was just a course of what we have to this here this class over here this class is for whatever you go on with us going against this letter this comes how you see the next thing we want to study what was this to be able to this keyword let's see about this so there was only this same connection and cause then I see we have seen in the and outside in the arguments this shooting has the something like this so I want to show you because so what's happening is this is the relation that we have to activity and so yeah I was making this on this random please come back and something now so happy. And that method are basically answer. So last thing I can make this simple is you just get this in the line. It is not going to work in the lights of trade basically. So I was making this wrong basically I was missing this wrong information that but it is wrong method. So is the method is trading class. So that you just hear that has a really so that this is the method which is important because in the shop class basically you can go not to the board and by the same that there is this wrong method. So what we are basically getting the our recent class. Now we should just say that so we will just see uniting how to go down to the first lecture of this section of class on the scale and class. We just see that trade from our subclass. So that is very important. So let's see how we can implement this. So in order to implement the trade, so let's see how this is written from the trading class. So first now we have this trade class in the subclass is the trade that we are going to get in class or the class. This one will be used. So slowly just do that for the two class method of the string. I'll just pass again to trade. So now you can make use of the trade. So you can see now we have made use of all the trades. So this it is not going to be successful, but basically this is not going to run simultaneously. Let's see if this runs or not. So I will just run the demo. Again, this is not going to work. You could see clearly class 1 is premiere first and slash because we want to just run inside and then we are done highlighting simultaneously. Also if this highlight trade was running simultaneously, it will show up I will create class 1 over here, class 2 over here, and you can clearly see first of all class 1 was executed. After that class 2 was going to be at least we have like system that you can creatively so in this class we have not just created. So in order to just consider here, so you have to make this is not very important because you have to surround the addresses we use is to let's get that address. So in order to see this phone let's go ahead and use this like another method and this is very important. So first of all show method of first this is important because you have to run your list to the trade this first thing. If you have one method in the class let's say instead of basically you will save this part running and let's this method again now since I want to class. So if you want to just override or make it so you will have 3 addresses over here. So inside this is just 2 and then that is analysis that we just next thing this is start method. So this addresses so what it means is first of all this is okay that the connection which is to second is fine which you do what the programming is simply this is just start out to send the method that we call this execute the case of connection that is going to use this start method the incoming connections method and the next thing so let's see how I so let's show it so this now the incoming connection so it is communicated so in order to do that we have this is now not this address and that is with this address here this is that class 1 was preserved now and class 2 was a connection we just give so we have succeeded in making the trade in items not extended yet. So let's see how this work for this one trade because this yet we haven't created that task in order to run the trade because it has simply started with the same trade because the tax is smaller but now let's see if the tax is bigger and this is going to run here our the tax is not so let's see it's so low it's still let me just you could see that now you could see over here so one there is a combination where you can see this one like this and it is in class 2 it is in class 1 like keyword and basically there is an instance there is also the class 2 and class 1 and here is class 2 and class 1 so now the tax is so large that it has now created the process where we can make these processes to run on the independence. So you could see so what process is so one process for that it doesn't even take a time because it's just saying that if there is any difference with this class one times the class for that I always can just will be every solution of this class so it is this I will have a small this time from let's go down now it's time to get not an exception. Not presenting every so that is always same. Okay, a class 1, class 2, I want to sleep maybe 1 second, and that's so second. I want to sleep so 1 second. Let's see this works and we can see the footsteps on the rhythm. From the devil gets to go here. And this is I want to sleep in the masses down. That the two swing are running together. You can clearly see class 1, class 2, class 1, class 2. Because now it's the time we just learn that module is on that class or the thread. Yes, running simultaneously. So basically trading technology. So in the masses with the head of multiple continue to the one houses is coherent people. So these are the supplementary is when the meters of the socket leaders morning can see what you just need to all that. That is a spicy border diagram. We just get these sockets of the socket is high dance. The some threads, running time so on the threads and the process is very much so I can select the movement. Shows up that the importance of everything to see the users of the thread line where I make you see the connection. I'll make all the backdoor, so see you in the next one, see you in the next one. Hello and welcome to this journey of making the reversal or backdoor with the help of Python. So in the previous lecture we saw how we can just connect these two client and a server through the socket module of a Python. Now let's see how we can just send data through these API calls. So you can see that this layer which is in the server part are optional, and you can see we'll see how to bind and listen in the next module. But now you can see that we have successfully communicated through the server and a client through the socket, and basically server is listening to the socket through some application. But in next lecture we'll just make our own Python in order to listen for the incoming connection. But for now let's see how we can send and receive the data between this server and client, because we have already connection set up in the previous lecture. Now let's see how this send and receive method of this socket module work further in our lecture. So you can see completely over here that server will receive first from the client is sending incoming request, and then it will send and basically client will receive that. So you can do this to and forth between this server and client. Now let's implement this and let's see how this work with our Python program. So first of all, let's go to the window. Let's open that module that we just created in the previous lecture, which was this file, Python file. So you could clearly see we have the connection established on this IP and on this port. You can also simply put another port over here. So after that we have to now send the connection. So in order to send that, you can see that we have to make use of this send module, and this is the send method which will just send some information back to the server. So let's see how this is done. So I'll just say that I'll just give some information. Okay, I'll just say successfully connected. So this will be the message that will be sent to this server. So let's see how this works. And okay, I just found that this Notepad++ doesn't support maybe backwards slash. So let's remove this. So I didn't find, and basically let me just make this statement saying successfully connected. Let me just give some spaces, maybe this will help. So we'll just make this connection, that is basically the connection between the client and server, and after there is a connection we have to send this message, and after sending you could see from these images that is after sending any request you have to close that connection. So let me just close that connection right here. So I'll just say connection should be closed, and let me just put parenthesis. Let me save this and let's go over here and let's see how this works. So first of all we have to listen for this port, and I have written the command in order to listen. So it is listening now on this port. Let's go over here and let's navigate to our CMD, that is our desktop, which has this Python file, and I'll just say backdoor.py is my file, and let's go, and it is showing us error. Okay, but if I just go back to the server, it is also showing nothing over here. So maybe we have some error sending that request. So let's see what is that error. So we have successfully got that value, but not here. So it is giving us some error saying that byte-like object is required, not a string. So it has shown us this error saying that basically, so let me just clear this first, and let me just save this again and run it. That is python.backdoor, and it is saying byte-like object is required, not a string. So if I just go back to our Linux, nothing is received. Instead we have to receive some bytes over here. So this happened because of this Python compatibility version. So basically, if you have the Python version that is 2.7, this will works perfectly fine. But now in Python 3.7 or the newer version, whatever that is basically from maybe Python 3.5 or newer, it had changed to something send to. From send they have changed to send to. So if you are using Python version that is newer than 3.5, send will not work for you. So you have to change from send to send to. So let me just format this real quick. So let me say message here, and instead of successfully connected, just writing over here, let me just cut it out. Let me just paste it here, which will be the message. Now what you need to do is we have to just go over here, and we have to first get that message, which is that message, and we have to first encode it. Otherwise it is not going to work. And basically this send to will have the two positional argument, or basically we have just given the one, which is the message, and this encoding technique, or basically encoded message, and after that next argument to this send to method will be tuple. So in this tuple you have to send now the same application, or basically the same IP what we just have here. So you have to just copy this, and you just paste it over here, the IP and the port number that this server is listening to. So this will be the IP address of the server, and this will be port of the server. So we have completed now. So this is the new way of doing things in the case of Python version 3.5 or newer. So let me save this now. Let's go over here, make sure our server is listening to this same port. Let's go here and let me just run it one more time, saying python backdoor.py is the file that is in desktop. Let me just go over here. I did not show any error, and you can see receipt is 23 bytes has been received over here. That means some information has been received by the server. So let's see now how we can send from this server to that of this Linux. So let's see how we can do that. So first of all, let me just go and make again this server listen on this port. Now let's go over here and change something. So if we go back here, and if I show you that what we have just done here is we have now use the same method in order to send from this client, and the server will receive data. Now we have to make use of this method in order to receive data from the server. When only restrict to this client side, we don't have to use to the server side. That means we can make use of only this receive method in order to receive data. We can't use this send because this send is for server, so we have to use this receive method in the client in order to just get the data, because we are only coding with the Python in the client side. We'll also do coding in the server side in the upcoming lecture, but for now we are only coding in the client side. That means we have to make use of this method, which is receive, in order to get the received data from the server. So let's go back over here. So the method is quite easy over here. So what we can do is we'll just say receive data,
and we'll make use of the same connection, and it will be the same method that we just saw, and the byte, that is this byte over here. And after that we need to just print this receive data. So I'll just say receive data should be printed. So that's it. We just use this receive in order to receive the data, and we just print it out over here. Hope this will work. And let's see if this works or not. So let me just say this one more time. Let's go over here and let's see our output is up and running. Let's go back here. Let me run that Python again, which is the backdoor file. Let me just hit enter. And now you could see that it is running. It is successfully connected. That means you can send data from this server now to the client. So if I type anything, this is a Kali Linux. You have been hacked. So if I hit enter, then it has shown that 42 byte was sent and it was received 23, which was the same code. And if you go over here, then you will see information right away. This is a Kali Linux. We have been hacked information because we have just print that received data over here. That means it will just show that data in this terminal or a command prompt. So you can see how we can send data from the server and client, and basically we can see that it has now received some data using this receive method of this socket API call. So this is the way to send in data and receive the data between the two computers using this socket. So in the next lecture we'll see how we can run now command from the server to this machine using some of the modules, and basically using the same module, but we have some method to do that. We'll see that in the next lecture. So see you in the next one.
Now let's start making our own backdoor. You can call also a reverse shell. So what happens is basically nowadays there is more advanced antivirus available in the market which has the database updated daily. So it is very hard for the attacker to just attack to the victim computer directly. So you cannot simply put any malware that is directly to the victim without passing through that antivirus. So antivirus will detect every bit of malicious code that is directly sent to the victim. So nowadays it is very hard to send directly the malicious code to the victim, but what you can do is simply you can make a reverse shell which will just make victim computer to connect to the attacker rather than attacker going for the connection to the victim. So that is the important factor of the reverse shell, because now attacker is not going to communicate directly with the victim, rather than they will listen for the connection, and when the victim will get communicated through that port, then attacker will just come to that port and basically there will be the connection and attacker can run any type of command on the victim computer. So we'll just make a reverse shell in this lecture and we'll just modify that reverse shell to the more advanced reverse shell in the upcoming lecture. But for now you can see in this picture that the attacker is just waiting the connection, or basically it is listening for the connection, and the victim computer will run that payload, and when that payload is executed it will just send a message, or basically it will just send the response to that port which the attacker is listening. So in that way there will be the connection, and also the firewall that is established on this victim computer won't get suspicious about this activity, because this attacker is not going to attack to the victim directly, rather than victim is going through the firewall to the attacker. That means there will be the connection, and antivirus won't get suspicious about this activity, and the attacker can get this idea working on these victims more easily than before. So let's make our reverse shell in this lecture. So first of all you can see here that I have these two computers, that is the Kali Linux. So this Kali Linux will be our server and this window will be our listener, or or basically this will be our client. So first of all, we'll just start with this Kali Linux. So you can see that if I just open the terminal and if I just type ipconfig, it has been configured with this WLAN interface. So now this server is only going to listen for some port. It is not going to run any Python code for now. We'll also make the Python listener code in the upcoming lecture, but for now it will only listen for the some port. We'll just execute that in the next minute, but for now let's go to this window machine, which is obviously the client. And here, first of all, I have downloaded my Python version over here. If I just search for ideally, and you could see the Python version. If I just open that ideally, let me just wait for a moment. Maybe it is not executing. Let me type cmd, and if I just type Python over here, you could see the latest version of Python over here. So this is the way. Basically I have just configured the Python in this Windows machine too. So the editor that we are going to use over here is Notepad++. You can also use Eagle or PyCharm. So I am going to use Notepad++. So first, the module that we are going to use in order to make the backdoor is socket module. So let's learn about this socket module at first. So this socket module is basically going to get a communication between the two PC. So this is going to give the connection between this window machine and the machine that is our server, which is obviously the Kali Linux. So this socket is basically what we call the standard module in order to have the communication between the loopback interfaces, or basically it will have the communication between the interfaces based on the port. So let me show you something that is with let me say first program that we are going to write is between the client and the server. So let me just go over here maybe and show you this picture over here. So you could see there is a bunch of API call to this server through this socket. So first of all, you can have this socket function on that socket module. You will have then bind, you will have the listen and accept, and after that client will also have the socket, client will have the connection. So basically what happens is server will have this layer that is hidden upper side. So client will have this connection that is socket through the socket, because the client is one which will get the privilege to have the communication with the server. So you could see it has established a three-way handshake with the client with the server basically. So the method that we are going to use is this socket and the connect method to just call this basically the socket API. So let's see how this works, and let me show you what we are going to do line by line. So we are just importing the socket module. So first of all, and now let me just make this connection variable which will have this socket object. So here what I am going to do is I am going to call that socket layer. So that is going to have the two parameter here. So first parameter is going to be, let me just type this first. So what is this parameter? So this parameter is very important parameter, and this specifies the address family. So you see here this socket module, or basically this socket method of this socket API call will specify the address family and the socket type. So you could see this is the socket family and this is the type. So this is type and this is the internet address family for IPv4. So this is to specify only the address family that is internet protocol of version 4. So next argument over here will be the important argument, and let me write first. So it will be also from this socket address family, and it will be sock stream. Let me first close this one. And what happened is here, that is, this is also the another argument, which is the socket type for TCP connection. And TCP is the protocol that will just have that will be used to transport our message in the network. So you could see we have the two arguments right over here. One is specifying the IPv4 family, and another is the socket type, which is this socket stream is the socket type for TCP. And TCP is the transport protocol that will just transport our messages between the network. So that means we have now connection between this client and the server. So let's go down now, and the first step is just having this connection. Now we have to use that connect method, and that is done through this connection object. And let's call this connect method now. So this connect method will take a tuple, and in this tuple the first thing will be the IP. So this will be the IP of the client, and the IP that I'm going to connect is the IP of the server. So let me just confirm this, if this is the IP of the server or not. So if I have to confirm here, I'll just type ifconfig, and you could see this is the IP address of this server. So let's go back over here. So next thing to this tuple will be the port where this will listen. So basically Kali Linux should have listened to some port, and basically this client will try to communicate, or basically try to connect through this socket package to that port. So let's specify that port. So let me say 4444, or you can also simply go to 8080, which is used by the web server. Now we have connected to this port, or maybe let me just say 4444, because I think 8080 will be used by the web server. So let's see that we have done these two steps. A simple step is done over here. So first of all, we just use this socket manager to just specify that we are just addressing the address family, and this is for the TCP communication. We are just connecting back to this IP address and the port. So let's go back to the server now, that is our Kali machine, and let's establish this connection. So before running this, we have to listen for this port. So let's go over here. Let me just clear first. So what am I going to do over here is, let me zoom this a little bit. And now first of all, we have to make use of this CNC application in order to listen this. So this VP is the argument for verbose, so it will just try to listen, and we have to now listen. So this EL is for the listen argument in the port. I have to give this P argument for the port, and this port should be same as we just passed over here, that is 4444. Let's go back and let's hit enter. Then it is saying listening on any means on this IP address, and basically this is saying 4444. That means it is just specifying the port which it is listening for any connection, incoming connection. So let's go back to our window machine, and now we have made this backdoor. Let me save this backdoor, and I have saved this backdoor right here in the desktop. So what am I going to do next is I'm going to just run this backdoor. So in order to run, I have to first navigate to desktop, and if I see the directories, that is right over here, that is saying backdoor. So in order to run any Python file, you will simply type Python and backdoor. I'll say backdoor.py. let's hit enter. Let's go over here in this Kali machine, and you will see that it has some messages showing us that connect to, and this is our host from unknown. So it is unknown for now, but it has given us some server or some client that is connected to this server. So you could clearly see we have now the hook between these two machines, which is done by simply with this Python socket module. So we have made successfully a connection between two PC. Now in the next lecture, we'll see how we can just execute some of the important commands in this client machine through the server, and we'll also see about the packaging, because if you see here, if you want to run this backdoor on the client, it is so suspicious that, because first of all it has to have the Python installed, which is not compulsory because everybody doesn't have Python on their machine. And the next one is, it is simply a Python file, so we have to package in a such way that the client won't get suspicious, and it will be cross-platform. That means it will be executed on any machine. It will be executed in Linux, Windows and Mac OS X. So that will be covered in the upcoming lecture. Whole series of the lecture will be covered about the packaging stuff and how to make your backdoor non-detectable by the antiviruses. So see you in the next one.
Welcome to this lecture. Now we have the another part in our socket programming, and that is our client side. So we have nearly finished our server side, though we haven't included any backdoors, like you may say the message backdoor or command executing backdoor, or basically it can be also the screenshots. We haven't covered that. We'll just cover in upcoming lectures. But before that, we have to see how this socket is going to work, or basically how this communication is going on, because we have written one command to list this connection. We can just try that command in order to see the connection that is happening between this client and a server. So we have to now code for the client section. So for the client section in the virtual machine, I have installed this Windows and it is up and running over here. I have made use of this Notepad++ to code with the Python because it is lightweight, so I do not need to install the PyCharm over here because the PyCharm is more heavier than this Notepad++. So I've just installed the Notepad++. We'll just run our Python code from this command line, and I have installed, that is the Python. You could see in here I have just downloaded the Python, the latest version of Python, which is 3.7 in this Windows machine. So let's start coding over here. So as always, the first is to import, and I'll just say that first of all you have to create, obviously you have to create the file. I have created the new file, backdoor.py. So the next thing I want to do is import some of this module. So before that, what you need to do is we have to just install some of the modules over here, and that should be done with the pip command. So what is basically the modules are this pywin32, and this pyscreeze is basically for the screenshot. So I'll just tell you that you can include, or basically you can download package all this with one go, and this WMI is basically for the Windows management instrumentation that will just track everything that we do in this machine. So let's see, and let's go here, that is in our Windows machine, and let's open our command prompt, and let me just open again. And here let me say something, that is first Python. In order to install that package, python yum pip, and install is the command to install the command, or basically to install the packages, and that is pywin32 and WMI. So you can simply say pywin32 pyscreeze, and next one is WMI. So let's hit enter and install that package first, because you have to install it, otherwise it is not going to be imported. And the next thing is to open your this Notepad++, and we'll just use some of this library that we just installed. So first one will be the system OS, and I'll also use the platform. We'll use the time in order to use that sleep module, and you should get this C types that is installed. And basically this is only some processes, and we have seen the SOP processes to execute the command in the Kali, or basically to execute the command in the client side. So this SOP process is basically to just call that methods like call method, popen method. So this will just execute commands in this terminal. So next thing what I want to do is the threading, and the last one maybe I want to install is WMI, which we just installed here. So after that I want to get the new command, and basically I want to import the another, that is win32, and this should be installed if you just install this package, which is right here, pywin32, and another is the WinError and win32 event. Okay, it is right here, win32 event, and let me just write one more, and that should be your last one, that is win32 to that should be maybe crypt. Let's see if this gets error. We'll just rectify. So the last thing what I want to import is from this win registration, I want to import everything. And I'll just tell you when we are coding that what is the importance of each of these. So before that, let me show you all of these over here. We'll just make this socket to just get the communication. OS is to directory file management. We work with this, and system and the platform. The main important here is the sub process, because this is going to make our backdoor to be executed in this machine, and this WMI is for the privilege of this Windows machine, and threading is for the thread operations. So let's start coding some of this manually. So first of all, I'll just say string host, and this host should be your Kali Linux IP address. So I'll just say 192.168.1.11 is my Kali address IP address. You can also check by typing ifconfig, and the next one is obviously the port. You should guess now, and the port will be 4444, which the Kali will be listening to. The next thing I want to do is to get the path. So let's see what the path we want to get. So that is from this OS module. I'll just say path, and it should be real path. We should have something that is real path method. And one of the biggest disadvantage of this Notepad++ is basically it doesn't have accurate command suggestion. So if you use PyCharm, that will be interesting because it gives everything that you need, and installing the package is obviously very much easier in the case of PyCharm. So basically what we are doing here is we are just getting this argument by the system, that is to get the file path. So basically this is to get the file path. So next is I'll just use this temporary folder to get the temporary path. So if you want the temporary path, there is another command in the OS that is going to be the environment command, and here we have to just give the app data, because if you know, in this machine or in any machine, or basically in the Windows machine, the temporary is after this app data. So we have just inserted this app data. Now integer buff, it is basically the maximum digit we want to include is 1204 bytes. So next thing I want to do is handle the mutex, or basically the function to prevent the multiple instances. So now before implementing the mutex in our program, let me know you about the mutex. So what is mutex? Mutex is basically the mutual exclusion. So what happens is basically, let me just take an example. Let me say I create this mutex, and next thing is I just update something that may be list. Okay, if I just update list, and now if I release that mutex, which is obviously the mutual exclusion, so this may be the operation. So let me just take example over here, that is saying this is the three operations that we do here. And what is about this mutex? So first of all, mutex is basically a function. Basically it will just prevent the multiple instances. That means if this is the operation update list, then this update list can be carried out or can be performed only by the single thread. So that is very important of mutual exclusion, that is no multiple can use, or no multiple thread can use this single list. So this is important because we want the operation to be done by only single thread. That means we can prevent now multiple instances. So in order to prevent multiple instances, we make use of a mutex, because thread can be used to do multiple tasks at a time, but I want only single thread to use this event to prevent from the multiple instances. So let's say we want to use mutex, or basically you can also check the documentation for the mutual exclusion to know more about the mutex, but the main idea is we want only one single thread to execute that operation to prevent from the multiple instances. So we'll just make use of this win32 event, which is just included over there, and now we want to use this create mutex method, and here the parameter is none first and one, and the third is your mutex. So the mutex is PA. Okay, so it should be PA, give this, and mutex and xp4. So this will be the way in order to create the mutex. You can check the documentation, there is nothing to say over here. It is simple the argument that is predefined with the mutex. Just remember that mutex is going to prevent the multiple instances so that single thread can execute certain operation. So next thing what we can do is to see if this mutex is executing or not. So in order to do that, we'll make use of this window 32 API and get the last error method, and over here we'll see if the error is already existing or not. So in order to see if the error is already existing, we have this win error that we just imported from here, and we'll just check now if error is already existed or not. So if error already, and there is command that is saying exists. So if there is already error exist, then what you're gonna do is, let me give the tab, and in that case mutex should be none. Otherwise, or basically if this is the case, if we just get the error, then you have to exit. There is no chance because there is error, we have to exit from that. So this is the way to just create the mutex, to try the mutex on your machine. So next thing is to try to see the sandboxy. So let me say you first the sandboxy, about the sandboxy. So let me open here, and this is the program that is going to be sandboxy. So what happens is, basically if you download any program, maybe let me say if I download any program from maybe torrent, so it can have some malicious code inserted over there. So if I download any file that look legitimate for me, but that can have any malicious code inserted, that can have also payload inserted with that file. So in order to just make your harmful file directly inserted to your system, there comes this program that is sandboxy. So what happens is, instead of just directly downloading and installing your program to the system which can contain some malicious code, first of all it will run on this sandboxy program, and it will just see if that is the genuine application or not. If that is the genuine application, then it will directly download, or basically it will install to the main system. If that is the program that contains some malicious code, and in that case it won't harm to the system because that will be run in the sandboxy application. So that happens basically if you just download any application that is from the malicious website. So instead of just harming for your computer, it will download it on the sandboxy, and it won't get any harmful code injected to your computer. So this is the application. So first of all, instead of just downloading our backdoor directly to the system, we have to now set this detect sandboxy. Okay, first of all it should be detect. Let's go over here, let's make some spaces, and I'll just say detect first and sandboxy. So this will be the method. So what we are going to do over here is, we'll see if there is sandboxy installed or not. So I'll just say okay, try, and here we have to first of all download that library. So I'll just say library handle, and in order to download any DLL files, we have this ctypes module in the Python, and in order to download we have this win_dll, and I'll just say load library method. So what this load library does, it will just take an argument in the form of DLL or any library. So the library that we are going to use for this sandboxy is SBIE_DLL, and it should be with the extension DLL because this is the DLL file. Let me just close. So this is the library, or this is the file that we're going to download in our window, so that we'll just install it, or we'll just install our backdoor in this sandboxy so that our computer won't get harmed. So next thing is to return, and I'll just say return me the sandboxy, which is obviously the string over here. And now let me just close this first. So this will be instances, so let me just close this first, and after that let me just return this from this method, which is sandboxy. So I have just misspelled it, it should be I over here. So we have now, this is basically the instances of the sandboxy. If we just download this DLL, it will just return that sandboxy. And I have already told that installing a backdoor directly to that system will be very dangerous. So first of all, we'll just see that in this program that is called the sandboxy, and basically it gives a sandbox which is to download the application and see if that backdoor works perfectly on that sandboxy. So next thing is to catch the exception, and if there is any exception that we catch and we don't know what the exception we are going to catch, so simply we'll write exception. Because we don't know name, that means we'll simply try to catch any exception that comes and we'll just return empty string. So we have defined this sandboxy, and basically just remember this is only the application where we are going to run our backdoor. So next is to detect the virtual machine. So let me just write some of these commands so that it will be easier for us after we just try to connect to the system. So I'll just give the tab again, and what this method is going to get us is the information about our virtual machine. Because if you know, we're going to run in this Windows, or basically you can also have the Mac or Linux in the virtual machine. So this method will get the information about the virtual machine and the OS that it has installed. So let's go back again. And in this detect VM, next thing what we are going to do is, if you remember, we have installed this package which is saying window management instrumentation. We have to make use of that module now. So here what I'm going to do is, I'll just say we object of WMI, because I have to instantiate that object, and it is this class which is WMI. So now what you are going to do is, you have to go to the query of the WMI, because we want the information about the virtual box, we want to detect the virtual machine. So in order to do that, you have the query in the WMI. So you can also search for WMI in the Google and get the information about this window management instrumentation. It will just tell us about the information, like it will just get the information about the status of local or remote computer system and the configuration and everything about the permissions. So this is the window management instrumentation, and we have to get the information of a virtual machine from this object now. So I'll just say for, not from, it is for, and I'll just make one interesting variable here, that is object disk drive. So if you just see, this is giving us a clarity what this variable is about. So it is about the disk drive that is installed in our virtual machine. So I'll just say object of WMI, and we have this method which is the query method in this object WMI. And if you see the query of this WMI, it is similar to that of SQL. If you ever have used the SQL, we have there the select statement. In order to select everything, we use this star method, and we use this from, because we want everything from Windows 32 disk drive. So let me just type real quick. So what we did was, we just made a simple query here saying that I want everything about the disk drive in that virtual machine. So next thing is, we just give a tab again here, because we are inside this for. Okay, I've just left here colon, and let me give the colon, let me give the tab, and now over here we have to now get the virtual box. So if virtual box is in, basically what we're taking here is, we want to give the information, or we want to source the information of a virtual box in this object disk drive. So in order to do that, we'll first see this object disk drive, and inside that we have this caption option, and we have to convert this to the lower, because we have seen here this is virtual box is all in lower, so we don't want any confusion with this string name. So we'll see that, or we can also search for the virtual. So this is to search for this virtual disk in that installed drive, and it will be also in this object. Okay, it is obj object disk drive, and caption again, and lower. So we are just searching for this string, and if we just get that, we want to return, you should guess that is your virtual machine. So I'll just say I want to return my virtual machine. So let's do that, and let's go up on here. Else, in the else part, or basically after maybe here, if we didn't get any information, we have to return something from this function. And if there is no information about the virtual machine, what you are going to do is we'll simply return that is empty string, which will be in the case of the live window machine. But in our case, we are just running in the virtual machine. We'll just get information about the virtual machine. So this will be wrap for this lecture. This has been long lecture learning about some of these modules and starting to build our own client. And in the next lecture, we'll see how we can connect to the server and do some operations. So see you in the next one.